Hello, everyone. In this review lesson number 5, we're going to cover linear inequalities and systems of inequalities. For the do now, we're taking a look at a store sells graphing calculators. The function g of x is going to represent the cost, or talking about manufacturing x calculators. What would be an appropriate domain for this function? So when we're talking about the domain, we're obviously talking about the input or the x values, which in this case is calculators. So what this question is basically getting at is what type of number set would best represent the number of calculators that you can manufacture. So obviously we can't have any negatives, we can't have decimals here. So which choice are we going to look at? So choice 1, integers. While the positives would be good, that also includes negatives, so no good. Rational numbers are fractions and decimals and things like that, so also no good, as well as negatives. Non-negative integers is going to be our solution. That's a very strange way of just saying whole numbers or counting numbers. And then non-negative rational numbers, that's the same problem that we ran into earlier where we could have decimal or fraction amounts. There are some cases where problems such as this would be something like choice 4, perhaps maybe if you're weighing something or something where there could be a decimal value. Not everything's always just going to be a whole number situation in the real world. To quickly review inequalities, remember when we graph a line, a linear function, or any graph for that matter, we're really representing the solution set of an equation. So the solutions are on the line. With an inequality, we're representing that with a region, basically half of the graph paper, the coordinate plane. So in this case, like all the light blue is representing the solution set. For the most part, we graph it the exact same way. We just have to pay attention to things like dotted versus solid lines and shading above or below the line, and we'll review all this as well. So you may remember this diagram from earlier in the year, but I like it. It kind of explains all 4 types. So let's start with the line type. So we're looking at the red and gray here. So a solid line, it's not like any thicker or bolder, like a normal solid line, is going to be any inequality symbol that includes the equal to component. That is greater than or equal to or less than or equal to. If we just have the less than or greater than, that's going to be a dashed dotted line, like we have over here. Okay, we're going to shade above or below depending on the symbol as well. So if we have greater than or equal to, we're going to shade above, kind of like word association there, greater than above. And if we look over here, any form of less than is going to be below. Okay, so for shading, I like to say kind of word association. For dotted versus solid, you're basically saying, hey, can the line itself be equal to? Then it's going to be solid. If it's not, it's going to be dotted. For systems of inequalities, we're graphing them together on the same axes. We're looking to see where the shadings overlap. We definitely want to label with any system. Very important that we're very neat with this. You don't necessarily have to color in every box. We've talked about shading in the past, just having lines. For system of inequalities, some people tend to just shade the solution set itself. They'll kind of see where the shadings would overlap, and then they would do something like this. They might just shade the actual solution region because these kind of can get messy depending on what your lines look like. But either way, as long as you do it appropriately, it's going to be correct. For word problems, look for keywords. Words like at least or minimum refer to greater than or equal to. At most and maximum refer to less than or equal to. These, I would say, are 4 of the more common inequality vocabulary terms. The rest are kind of straightforward. These ones are the ones that also people tend to confuse. At least kind of sounds like less than and vice versa with at most. So people tend to choose the incorrect symbol, but remember what these 4 words mean. With word problems, if we're graphing them, it also can sometimes be easier to graph using standard form. The scale may be, adjusted by 10s, by 5s, where slope isn't really going to work out that appropriately. All right, so we'll jump right into a practice problem here. We're going to sketch the graph of negative 2y plus x is greater than or equal to negative 8, and then we're going to analyze whether a point is in the solution set or not. So the first thing I'm going to do here is copy down the inequality, and I'm going to get it in a graphable form. One thing that was not mentioned earlier, we want to make sure with inequalities, when we divide by a negative, I do want to flip the direction of this symbol, so now it's going to be less than or equal to. That's going to be positive 1/2. Some people tend to panic when there's nothing in front of x. Put a 1 there if it helps. Plus 4. And when I graph an inequality, I like to write down all 4 things. Obviously, your slope and y-intercept, but also your type of line and where to shade. So what type of line is this going to be? It does have the little equal to bar, which means it is going to be a solid normal line. The shading, remember our word association, this is a less than. We're going to shade below. I'm going to begin at 4 on the y-axis. I'm going to move up 1 over 2. I can move backwards by going down 1, left 2. Normal solid line. And shading below this line, think about it as a kind of like 3-dimensional object. Below the line would look like this. With shading, you don't have to sit and color in every single box with like a charcoal pen. You just have like the lines coming out of it like this. I like to go all the way to the edge of the graph, and that's our inequality. Now let's plot that point and see where it's at. -1, 4 is right here. So it's pretty close, but it's not going to be in our solution set. It's outside the shaded region, doesn't satisfy the inequality. Any explanation like that would help. Outside shaded region, therefore not in the solution set. Algebraically, you could plug it in and show that it doesn't work either. And that's all she wrote. All right, so multiple choice practice. Which point is a solution to the system below? These are kind of annoying when they're given as multiple choice because obviously you probably don't want to sit and actually do the whole graph and then just choose. Basically, it amounts to kind of just selectively guess and check and plug them in, hopefully finding which one works, and it's not your fourth and final choice. Maybe we'll start with some of the easier ones here. So if I plug in 0, 6, that's not going to work right away. So 2 is out. If we plug in choice 4, that looks like it's going to work. So that worked out kind of nicely. I was choosing the ones without the fractions in them. Let's just quickly verify that. We get, that's going to be 36 plus 4, so 40. 40 is greater than 4. And for the bottom inequality, we're going to get 2. That's going to be 18 plus 4 is 22. So choice 4 works. They've asked this a few times, and like I said, it's kind of annoying. We might have, had to sit there and plugged in all 4 of them to arrive at our answer. But if you have the option like I did, start with some of the easier choices. For number 3, which graph represents the solution set? If we look at the lines, if you kind of like unzoom your eyes a little bit, all the lines are the same. It's just the shadings. So which one has been shaded correctly? So x plus 3 should be shaded below. So like this one is no good. And this one is no good. And the other one should be shaded above. The negative slope should be shaded above, which is shaded below here. So choice 3. All right, for this one, we're going to rate the inequality represented by this graph. So it could help to write down my pen's skipping here. Could help to write down your information first. So it looks like the slope is up 2 over 1. So the slope is 2. The y-intercept is going to be -3. This is a solid line, and it's shaded above. So let's put that all together. Solid tells me I need the equal to. Above tells me it should be greater than. So put that together, greater than or equal to. And then obviously just 2x minus 3. That's your normal m and b stuff. On the same set of axes, we're going to graph that. I'm going to get it in it's in standard form. I'm going to get it in y equals form, slope intercept. Divide by 2, we get Okay. I'm going to begin at 2. I should erase those other 2 dots. And I'm going to go down 1 over 2. down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. I'm going to make a dotted line. And I'm going to shade below. It's dotted because it's just less than. There's no less than or equal to. And it's shaded below because it is saying less than. You could label it, if this isn't technically a system because they gave you the original one, it wouldn't hurt to label it, but you didn't have to here. Oscar thinks 2-1. So let's plot that. That's right there. Oscar thinks 2-1. Is he correct? Do you agree with them? Blah, blah, blah. So Oscar is incorrect. He should have listened to Angela and Kevin. No, he's incorrect. 2-1 is at the intersection of the two lines. However, the one we graphed is dotted. So he's incorrect. It's not in the solution set. It's not going to satisfy. I'm running out of room to write, so more so just listen to what I'm saying. It's not going to satisfy that. If you plug in 2-1 to the x plus 2y is less than 4, it doesn't work. So it only satisfies one of the inequalities, not both. So it's therefore not a solution to the system. All right, we're going to look at a system of inequality word problem. We're selling iPad chargers and wireless keyboards. Maximum of 14 items are sold. He earned at least $342. Each iPad charger is $18 and it's $38 for a keyboard. We're going to write a system of inequalities that models this. So they do announce the variables, so we don't have to use let statements here. We're going to be using X for iPad and Y for keyboard. So a maximum of 14 items are sold, and these are the only items. So maximum, remember, means less than or equal to. Okay, second inequality is going to be our money one. So $18 for an iPad charger and $38 for a keyboard. And I made at least 342. At least means greater than or equal to. Part B, yeah, we're going to graph it. So for this, let's see. Let's start with our first graph. So I went ahead and finished the graphs of these two inequalities. This is what we referred to earlier. Sometimes it can be faster to graph just using the intercepts alone because you're just plotting 2 points. We do not want to put arrows on these, and it's very important that we label. Also notice I just shaded the actual overlap. You can shade everything and then just kind of put an S or make sure to highlight where they are overlapping. But for systems of inequalities, you can also just do this and just shade the actual solution set itself. Didn't have to adjust the scale here. There was enough room to fit it. Had it been something larger, you want to go by 2s, by 5s, but I just went by 1s. And now let's look at part C. Is it possible that we can have 11 and 3? So 11, 3 is going to be right here. It's close. My lines are a little sloppy, but that's not even going to be in the shaded or the double shaded region regardless. So that's going to be no. You can also plug it in and show that it won't satisfy the inequalities. It's not going to satisfy, I believe, the second one, or the bottom one. No, not in shaded region. Algebraically, it's not going to satisfy the one with the 342, I believe. If you only sold one charger, what is the least amount of keyboards that would work? So one is right here. So the least amount, it looks like, obviously we can't have whatever this is. This would be like 8.5. So it looks like 9 would work. So 9 keyboards. Obviously it's going to be less than or equal to 14. And we can algebraically prove this as well. We can plug in a 1 for x. And now if we do 324 divided by 8, I don't think that goes in evenly. Let's see here. We get 40 and a half. Oop, messed something up there. Hold on. 8.5. I was gonna say 40 and a half. 8.5-ish. So we were pretty close when we were just estimating that. So this is one of those cases where we have to round up to the nearest whole number to say 9 keyboards. Could have just looked graphically, but this is algebraically showing it as well. And that wraps up our lesson on inequalities and systems of inequalities. Thank you for watching and have a great weekend.